So welcome to 2009 question A4. So the 3D graphic on the right shows the plan elevation of a right base cone. A 3D graphic is also given below. A point P on the curved surface is shown in the plan. Part A, locate point P in elevation and draw the projections of the sphere which rests on the horizontal plane. So the circle will be a tangent to XY line which touches the cone at point P. So I need to get point P in elevation. So I can draw a line from through the center of the cone, through point P. It's the base. This is an element. I can bring this up now to the XY line, join it back to the apex, because if 2 points join one view, they join every view. And locate P there in elevation. Now, draw the projections of a sphere which rests on the horizontal plane and touches the cone at point P. So I need to rotate P out until it touches the extreme generator and find it in plan. So P1, P1. Now the sphere is a tangent to the extreme generator and the horizontal plane. So what I'm going to do is get my compass, set it to any radius, and I'm going to bisect the angle between the extreme generator of the cone. So that's the extreme generator, EG, and the XY line. So the center point of our sphere is going to lie somewhere along there, but we're not sure where exactly it is. But the sphere is a tangent to the extreme generator. So from maths, if we have a line that's a tangent to a sphere, the center point is located between a line during the center and the point of contact, and it makes a right angle to the tangent. So to work that in reverse, we're going to draw our normal line perpendicular to the extreme generator from P1. So where that intersects the center line, that's the center point of the sphere. We're going to find that now in plan, and we'll have to rotate it around. So I'm going to drop that down, drop this over, and that's not the radius. Here's the radius of the sphere here. So that's the construction sphere. Here's the sphere in plan in its construction position. Now, to find it in plan, we're going to put our compass on the center of the cone. We're going to rotate the center around. The point of contact between a cone and sphere lies in a line joining the apex and the point of contact. So the center of the sphere, and that touches the cone lies in a line joining the apex of the cone to the point of contact. So here's the center point of the sphere. So the radius remains the same. Now I can find that in elevation by bringing it up and then bringing this across. There's the actual center point of the sphere, the red sphere in elevation. I'll do the heavy and hidden detail later. It was a bad question the way they heavied in the cone when it shouldn't have been. Now, part D, determine the traces of a plane which is tangential to the cone and the spheres. You have to determine where this blue surface that touches the red sphere and the cone intersects the vertical plane and the horizontal plane. Look, that line HT and VT, they're the traces. So what we're going to do to solve this is we're going to wrap the sphere with a cone that has the same base angle as the extreme generator. So they're tangential. So how do we do this? So in elevation, we're going to draw a line that's tangential to the sphere, so I'm going to draw a line that's tangential to the sphere. Okay, so there's the apex of the sphere, or cone rather, sorry, cone that contains the red sphere. Sorry, that's miles off. Now, we're going to find the plan view of that cone. So, I'm going to drop this line down. I'm going to draw the center point across there. So I'm going to draw in a portion of the cone. So just a portion of this cone, not at all. Right, and then the HT is going to touch the two circles in plan. So you can just line your set square up with them. Doesn't have to be particular. Okay, well, it does. It touches the two circles. But what I mean is you don't have to do any constructions. Now, to find the VT, what we're going to do is we're going to draw a line that's parallel to the HT in plan. And where it hits the XY line, we're going to go up and go parallel to the X or Y line elevation, because parallel lines are parallel in every orthographic view. So I'm going to draw a line parallel to the HT through the apex of one of the cones. Now, where that touches the XY line, I'm going to go straight up, and then I'm going to go straight across from my cone. So parallel to the horizontal plane, or HT I should say, and then I can draw through here, and there's the VT. Alright, now this I'm going to heavy over in pen now, which is kind of going to ruin the actual drawing, but you'll get to see it better. So the sphere in plan, the red sphere, is all heavy detail. The cone should actually be, that portion of the cone should actually be hidden detail. Then this cone here, or sphere rather, sorry, in elevation should be heavy. And you don't have to heavy in the second cone as it's only a surface. And then this should be hidden detail, this portion of the extreme generator. And that's the question done then. Cheers, thank you, bye bye.